Hello, my Algebra 2 friends. So we are back. This is section 1.3. It's the second half of the lesson, though. This is still algebraic expressions, but we're going to focus on word problems and applications. So the big idea, I think the best takeaway from this lesson today is to understand that in math and in science, variables mean something when they come to an application question, and you have to be really specific and, of course, accurate as to what those variables represent. And once you can kind of wrap your head around what the variables represent, then the algebraic expression usually kind of falls into place after that. This is one of my favorite sections. I really like it. I tried to get a little more creative with the story problems the past few years, so we'll see. We'll see how you like it. All right, so number 1 in our notes, we have a salad bar charges $3.50 for an empty container, and then you're going to be charged 45 cents per ounce of food. So you fill up that container of food as much as you want, and the more you get, the more you pay. So the following model represents the total cost or complete cost of your shopping trip. So T equals 3.5C plus 0.45D. So they've already set up an expression for you, or an equation technically, and they've given you variables to think about. So what do all these variables represent? And here you want to be really specific, but be accurate at the same time. So T is, I always think of it as the total because it's like T equals, so that's what the customer's paying. So you could say the total cost, or you can steal some words straight from the problem. It says the complete cost. That works for me. All right, now here's where it's going to get a little dicey. C, what does C represent? So 3.5C, those are joined together in the mathematical expression, which means the real world, they have something to do with each other. So the salad bar charges $3.50 for an empty container. So this is where kids get things wrong. They say C represents containers. And then I would say, what about the containers? And then they would say, the cost of the container? No, we know that the container costs $3.50. What we don't know, what's unique to every single customer, is how many containers they go and buy. Because maybe I got my 2 kids with me. I got to buy 3 different containers. I don't know. Maybe they're going to share one. That's dependent on what the customer wants, right? So this C represents the number of containers. And I think that's a good takeaway for today. Variables represent things in the problem that we don't know. They're variable to each customer or to each situation. The number of containers is going to change depending on who's at the register. And then D right here goes along with the 4.5, so it's 4.5 per ounce of food. So the 45 cents is what you're getting charged every time you add weight to the container, right? So every ounce it goes up 45 cents. So D does not represent how much you charge for the food. It does not represent anything about the 45 cents. It represents the number of ounces of food. So another way to say that, and I would totally accept this, is the weight of the food in ounces. I think that's a perfect way to say what D represents. So that's our first task. Can you, if I give you an expression, can you come up with what the variables are very specifically? This diagram here represents how you solve an application question in algebra. The thing is, it looks really complicated, but a lot of these steps happen very, very quickly. The problem we find in algebra is that we have a hard time recognizing that our human brains are beautiful and wonderful and think really fast, just like a computer would. But a computer is not programmed until the human programs it. So you have to think like you're programming a computer at all times when you're working with algebra, because that's essentially what it is. The computer knows nothing until you tell it. So what we're going to do on part of this today, and you're not going to like this part, we're going to write a verbal model. So that's going to have words in what looks like an algebra sentence. And I'm pretty lazy and I don't write really well, and I surely don't spell very well. So sometimes I abbreviate, which is dangerous, but Then we're going to assign variables. So I don't want to have to write like 3 words to represent like the number of cheeseburgers. I'd rather just use X or whatever. Then we're going to use those variables and write algebraic models. And this happens very quickly. It really does, I promise. If we sometimes have more information, we can actually solve or evaluate the algebraic model, and then we can give an answer. And ideally, we're going to give an answer like a human would give an answer, not like a little algebra robot. So this question is about a personal trainer who charges $20 per month for the client plus $17 per hour for each session of training. So create an algebraic model that determines determines the total cost C, which they want you to use C for that, for a single month of personal training with an unknown number of hours. So just how much would a customer's bill be per month based on those two factors? So the verbal model is the part that kids don't like, because you're supposed to write out words, and I know you're like, I already know what to do. Great. Write it as a verbal model, because my job is to teach you how to train a computer later. All right, so total cost. That would be, well, we'd have to consider the monthly charge, because maybe eventually the trainer raises or lowers that monthly charge. So monthly charge, or fee. All right, I don't know how sensitive this microphone is, but my child is running around upstairs like an elephant, so sorry about that. And then we're going to be charging the customer for every hour of training. So the charge that they do per hour, right? So hourly charge, I'll call that. There's probably better ways to say this. I'm not so good with the words today, you know. And then that would be dependent on how many hours you actually go and visit the personal trainer. So number of hours. And notice there's a multiplication sign in between those. I think my husband's upstairs also making elephant noises. I'm sorry. Okay, so variables assigned. They already did this part for you, which is kind of awesome. They said the total cost is C. So that's already up there. And then unknown number of hours is H. Now notice they didn't say anything about hourly charge and monthly charge. That's because they are not going to be variables to us. Variables are only things that are unknown and are fluctuating between different customers. Everybody gets charged the same monthly charge and hourly charge. So the algebraic model would be total cost, C, equals the monthly charge, which is $20, plus the hourly charge, which is up here, 17, times the number of hours, which will fluctuate between all the customers, so H. So this is the algebraic model. That's what we would program a machine to do. Maybe you have some sort of an app or an Excel spreadsheet or a Google Sheets where you have all your clients like put into there and you can just enter how many hours they do. There's lots of reasons why we need to know this, guys. I'm just trying to throw some real basic ones out there. Why is my pen in the middle of the way? All right, so now let's use that model. Let's say I have a particular customer and I need to charge them for 7 times per month for this particular month. So this customer, $20 plus the 17 per hour, 7. I can't do that in my head. Good thing I got my trusty calculator here. Or better yet, I programmed my computer to do it. Oh man, and see, I just typed it in wrong. So if I had this programmed, I wouldn't have even had to mess with this. All right, so I need to charge this lady, ooh, good luck lady, $139. I hope it was worth it. Good personal training, I guess. All right, let's move on. Let's look at this example. And this example is very similar, except this time we are, oh man, we're going to buy some things for our friends or somebody. You have $650 and you're going to buy some movies on DVD that cost $15 each. Write an expression that shows how much money you will have left after buying end movies. So I know, in a normal world, would you write an expression for this program of Google Sheets to calculate it? No. But the sentiment is there that we could for something more important and bigger, like a cash register per se. You know, how much change do you give the customer? You guys don't have to calculate that because the machine already does. So verbal model, you would take your original amount of money, which we already know it's $650, but remember this is a verbal model. And then you're going to subtract off the cost of each movie or each DVD. But then what if I buy 2 or 3 or 4? So I also have to multiply that by the number of DVDs. Okay, and that's what's going to calculate how much money I have left. Here, they did assign me some variable here, so... And notice they only assigned us one variable, because that's the only thing that's going to change from problem to problem, situation to situation, is how many movies did I actually buy. Because we know everything else. All right, so the original amount was $650. I have $650. And then I'm going to subtract from that the cost of each DVD, which is given to you up here. It's $15 each. And then times a mystery amount of movies. That's the algebraic expression that tells me how much money I have left. Oops. I wasn't supposed to put that there. Just move that down. It's supposed to go there. Okay. So the variables assigned was n, and n represents the number of movies, number of DVDs. All right, what generation are you guys? Gen Z or something? For whatever you guys are. This is not a hashtag sign. This is a it's a number symbol. It's also a hashtag sign, but I had to explain that one year and I felt really, really old. All right, so now let's evaluate and solve. Let's say I think I want to buy 23 movies. Is that even possible? If so, how much money will I have left over? Well, let's calculate it. 650 minus 15 times 23. I'm not doing that in my head. Because it's not even July yet. It's June. For me. I know it's not June for you, but $305 left. Man, I could buy a whole lot more DVDs. Now, the part I've been kind of skipping here, because I'm tired and I shouldn't do this. I should be giving my answer as a human. I should be saying, if I were to buy 23 movies, I would have $305 left. Like, I should write that sentence. Because here's the thing. In the real world, the people who do the math for other people, whether it's computer programming or, designing a model that kind of explains how something's going to behave in a factory, or doing prediction or analytics, you don't run up to somebody in a boardroom and just spout off algebra with no explanation. They need a lot of explanation, and you need to talk to them like they're a human. So those of us moving on in the math world, we need to really get used to realizing that not everyone likes math, and they surely don't want to hear about your math. They want to hear it like a human. So keep that in mind. Oh, coffee. All right, you guys don't know me well enough yet, but I love coffee. All right, so your team is setting up a computer program for a popular coffee store. At this store, you make a single donation of $4. The customer would make a single donation of $4, and then every drink after that, or every drink, costs $2.40, but you get the first 3 drinks free. Kind of, but you made a donation, but whatever. So they went ahead and said T to represent the total cost, use C to represent the number of drinks ordered. They want you to create an algebraic model that calculates the customer's total bill. And then just for easiness here, let's assume that everyone's going to order at least 4 drinks. Because if you already get 3 for free, why wouldn't you just go get a 4th, I guess? This is a very real life situation that someone would want to program a special on a register. I mean, let's be honest, I'm talking about Starbucks here, right? I dream that Starbucks would do this because look at how much coffee you could get that'd be great. But it's not part of their program, so someone would have to program it, and they would have to upload in their register this particular setting. So that's kind of cool. Hey, Starbucks, you want to give a lady some coffee? I'll be willing to drink Starbucks during all my videos, if that's what it takes. All right, verbal model. So let's talk about this in words. This part is painful, I know. So the total cost, meaning to the customer. Well, there's a few things they're going to have to do. They're going to have to pay the donation fee. That's an E. And then they also would be charged for every drink. So cost of 1 drink, I should say. But then you'd multiply that by how many drinks you pay for. So I'm going to say the number of drinks. Now, normally I'd just say number of drinks, but this one's a little tricky. Number of drinks you pay for. This is not the best way to word that. Let's talk about that. Okay, variables assigned. They kind of went ahead and did this for us, right? They said T to represent the total cost. So T equals total cost. And then C represents the number of drinks ordered. Now that's a little tricky. Talk about that in a minute. Now, they didn't give me any other variables because those are the only 2 things that would be variable between each of the customers. So let's kind of throw this down using our verbal model. Total cost was T. The donation fee is flat. It's a $4. The cost of 1 drink would be $2.40 today. And this is where it gets kind of crazy. Oh, she put down parentheses. That's not good. All right, so parentheses. So I'm going to put this C down. But C represents the number of drinks I ordered because they have to still make my drinks, right? So I drive up to my local coffee chain. It's Starbucks. And I order 6 drinks, but I don't pay for 6 drinks. And remember, my verbal model was 240 times the number of drinks I pay for. The reason I don't pay for 6 drinks is because the first 3 drinks are free. So right here, you're going to have to take the number of drinks that you ordered and subtract 3 from that. That's how that algebraic model is created. That was sneaky. That was really, really sneaky. Okay, so remember, you're programming a computer who doesn't understand what's going on until you tell it what's going on. You still got to punch each of the drinks into the register, right? And they're all going to be delicious. But I'm not paying for all of them. I'm paying for, all the ones I ordered, but minus the first 3 drinks. All right, that was a good time, right? One more, we got it. This gift shop is advertising that they're going to engrave anything I purchase in the store at a rate of 6 cents per letter. And I'll give you the first 3 letters for free. I don't know what I have with the number 3 today, but apparently that's showing up a lot. The desk plate that I want is $22. Write an expression for the total cost of buying the desk plate and having it engraved. So again, depending on what I want engraved on it, the price is going to be different. So what a shock. We start with total cost. Are you noticing a pattern here, guys? Total cost. So the customer would pay for the product. So cost of, I'll say item, because maybe I don't want a desk plate next time. What is a desk plate? Like one of those metal things that just have your name on it. It's a really lame gift. Okay. So besides buying the item, you're also going to pay for any engraving. So in addition to that, you're going to be charged for the cost of each letter. Kind of. And then similar to the coffee problem, you're going to multiply that by the number of letters that you pay for. I go with that hashtag again. All right, so variables. They didn't tell me variables this time. So the things that are going to be different for all of the customers would be total cost and then the number of letters that we are paying for. That's going to be different, right? And I'll come back to that idea in a minute. So I'm going to get crazy. I'm going to use C for total cost this time. It could be anything. It could be a picture of a unicorn. I don't care. C is the total cost. And then I know the other 2 things, but I do not know. And then I'm going to change this up a little bit. I'm going to say N equals the number of letters. And I'm just going to stop that. Number of letters. We'll talk about why in a minute. All right, algebraic model. Total cost. We're now representing as a C. Cost of each of the item, for me, it's $22 apparently. I guess they only sell desk plates. My bad. Cost of each letter is 6 cents. But I can't put an N here, right? Because if I want 28 letters, I don't actually pay for 28 letters. I don't get charged for 6 cents for all 28 letters. I really am only paying for, so the number of letters you pay for, this N, but minus 3. And the minus 3 part comes from this guy. The first 3 letters are free. That's where this is coming from. Okay, easy enough? So y'all are ready to program some registers. You just got to learn like a computer language and you're off. Yeah, I'm kidding. It's way more complicated than that. But this is a good start, right? Algebra 2 in particular is kind of your launch pad out into college level math. And we're just getting all of our base level math shored up so we can move on and do some really crazy stuff next year and the year after and the year after. All right, good luck, everybody. There should be some practice problems. You do them right away. Let's get that retention so everything gets stuck in the brain. All right, good luck.